Assalamualaikum and greetings everyone. So today we would like to present of our project for subject EC3213 Structural Analysis 2. We are from group 12. Firstly, I will introduce our group members. My name is Muhammad Akmal Arman bin Saiful Madzi. My matric number is 194350. Next.
Hi everyone, my name is Dinesh Karambadi Analakiraman and my metric number is 197463.
Okay. Hi everyone, and my name is Hanis Natasha binti Hailim, and my matric number is 198089.
And I am Najwa Shamina, 199277.
All right. So let's start off with the introduction of our project. Okay. So this project, uh, we are trying to understand how Eurocode works. So for all of our information, Eurocode is actually a design code that is introduced and proposed and used by the European Union countries for structural or for all kind of structural design, be it reinforced concrete, steel, and others. So this code is meant to unify the design philosophies and make civil engineers more productive across all Europe because we know if we have different kind of design code, that that will make them confused and there will be conflicting issues when they're trying to design their structure. So in this project, we will try to establish a firm understanding in terms of loading analysis, the ease of use, and technological advancement. In this case, we are trying to use softwares to support our manual calculation. So by considering the loading and analysis of beams, slabs, columns, and foundation footings. But in this case, we do not regard we disregard the foundation footings because have that will require a different kind of analysis, mainly in foundation engineering and structural mechanics. So moving on to our problem statement. Okay, so structural building analysis is a preliminary phase to determine the effects of loads on physical structures and their components. So the analysis refines the problem definition or description by eliminating important from information provided and by putting together essential details. In this project, we are required to analyze a six-story building by providing a comprehensive report of the building on 2D and 3D structural models, as well as our hand calculation on a simplified 2D model. So we have selected uh, three uh, three sections of the subframe of the 2D subframe model. Moving on. So in this project, we assume that uh, the design will have adequate supervision and quality control during construction. We also assume that the construction will be handled by professionals who practice good workmanship. We also expect that the materials that we design adhere to the standards of Eurocode and not any other codes. Also, we expect that the building will have regular maintenance as long as it's sorry throughout its life cycle. We also assume that the building is heterogeneous, meaning that there won't be any uh, changes, or should I say, any deviances in the shape of the building. We expect it to be exactly 40-meter long, 40-meter long, 18-meter wide, and yeah. Also, we expect no other dynamic load. Dynamic loads such as changes due to temperature or wearing and all that.
Okay.
All right. Next, methodology.
Okay. So in this methodology, in order to perform the manual calculation, we have first determine the manner of the load distribution, which is either one way or two way from the length of the beam and column. So we determine the load cases from the based on the loading QK and GK, and then we find the load which is W equal to uh, width over 2. So next we find the moment of inertia for the column and beam, the member stiffness, distribution factor, and fixed end moment of each member of the particular longitudinal section, because we're going to perform it using the method of moment deflection method table. So we apply the fixed end moment into the moment deflection method table, and then we distribute the moment among the connecting span and carry the moment in each span over to its end. So after we calculate all the carryover moment until it becomes 0, so we summation all the moment to find the moment. Okay. Next, based on the value of the moment, we can find the reaction force and shear force, shear force, and moment. So we can draw the shear force diagram and bending moment diagram. Okay. Next.
And for the result that we managed to get from the manually calculate, and we calculate for subframe for roof, first level, second level, and ground. And here is the shear and moment that we get from the manual calculated. And for this is for EC, and here is for VC. So for the next table, we calculate the difference of bending moment between Eurocode with safety factor 1.35 GK plus 1.5 QK, and the BS British Standard with safety factor 1.0 GK plus 1.0 QK. And so for the percentage of difference, we managed to get the average of about 45.48% for the difference. And the next table, we calculate the percentage error between manual calculation and software, LinPro. We're using LinPro. And we get the error is about 0.68. Okay, for the next limitation, Dinesh will
Explain more.
explain more.
Okay, I'm going to explain about the limitation. For the limitation side, we have been faced several problems for this project. The first and major problem that we face is that the 3D software at SAP 2000, which is a student version, so it can only analyze structure up to 100 nodes. To sort out this problem, we have decided when the length of the building is 40 meters spanning over 100 sections, we cut short of each length to 12 meters and 3 sections. The rationale behind this is that the elements will bear the most precise result as much of its sectional dimensions are still intact. If we were to use the original length, each slab will be 13.33 meter long and 9 meter wide. That will be obviously deviate from the original design, thus giving off inaccurate design calculation. For the next one will be the next problem we faced was the calculation of 2D software and 3D software contradicted each other. So LinPro only have the capacity analyzed by by members of frame of the selected axis. It does not compute the force and moment coming from the third axis, unlike SAP 2000. So the value of LinPro analysis will vary from the SAP 2000, either smaller or bigger in value. Hence, only the analysis from SAP 2000 should be considered seriously when designing the structure. But as stated previously, the analysis by SAP 2000 was impeded by the 100-node limit, and alternative design was used instead to mimic the original design. So neither software was actually intended for a comprehensive analysis of reinforced concrete in accordance to EC. LinPro was designed to analyze 2D structure without taking into account of its member composition, steel rubber. While SAP 2000 does provide analysis of steel rubber, users have not freedom to tweak the details. Both software may be used as preliminary analysis, but they are in no way adequate to determine whether each member of the frame will fail or not. So another one limitation is the calculation greatly vary due to different placement of decimal point. 2D manual calculation are done by using calculator. So for each value that we obtain is rounded to the nearest 3 decimal point for writing purposes. Hence, every step the value is rounded, thus affecting the final value. However, the 2D and 3D software directly calculated without rounding the value every step of the calculation, thus giving a more accurate value. For lastly, 2D manual calculation can be done as many as 3 degree of freedom when attempting to solve 3D manually. It will reach up to 12 unknowns, which is simply impossible to solve using conventional calculator. So next will be the conclusion and recommendation. So based on the setbacks we have faced toward this project, we have several recommendations towards the structure. Mainly, it involves utilizing more different structural software from which we can assess and determine its mean value. Some software have different degree of accuracy, thus we cannot solely depend on a single software. We must diversify our sources to achieve a more accurate result. One of the best software for RC design is Orient. Users can input their loading and the software will provide a full outcome of not only reaction but specification of each member of the frame to fully serve the client's need. We should have saved our time and OPT for Orient instead. It is also recommended that we determine the value of modulus of elasticity and it consistently throughout the calculation. It is observed that LinPro and SAP 2000 may not have the same default E, hence the discrepancies in the result. By and large, this project aimed to analyze the 2D and 3D structural model as well as the manual calculation of 2D model, and we have done so, albeit with moderate success. We have determined and compared the value of bending moment, shear force, and also reaction of the structure with different approach, manual 2D software and 3D software. We deem the values to be of the same to a certain extent. There are some discrepancies which have been suggested of its solution. Part of the journey is the end. With COVID-19 almost passes, we wrap up our project with the conclusion that it's a success. That's all from me. Thank you.
Okay, that is a wrap for our video presentation. Thank you and goodbye.